All right, hi all. I'm back. I'm going to do two separate shorter videos on polar roses. R equals some number times either sine or cosine times n theta. Turns out if n is even, you get two n petals. It turns out if n is odd, you get n petals. And the odd case usually has a period of 180, so it actually goes around twice in 360. And the even case goes around once in 360. Now, all these things you can determine for yourselves in uh, in Blackboard. I have this set up for you nicely, and you can also read the textbook, and you can use your calculator to verify what I'm saying. So this first video on polar roses, I'm going to look at y, or rather r equals sine of 2 theta. Okay, and I'm going to take a little bit of different approach here. Instead of taking the approach of a table of values, what I'm going to do is I'm going to be looking at the sine curve, the regular sine curve, but actually two of them from 0 to 720 degrees. That's the sine curve twice. And then we're going to look at, as theta goes from 0 to 45, 45 to 90, 90 to 135, and so on and so forth, uh, increasing 15 degrees each time. And then 2 theta, if theta is going from 0 to 45, 2 theta is going from 0 to 90. If theta goes from 45 to 90, then 2 theta, I'm just doubling everything, goes from 90 to 180. And this entire chart will be up on Blackboard. So you can look at it now, but I wouldn't worry about taking notes. You can get that off of Blackboard. Similarly, as theta goes from 0 to 135, and you'll see why I'm picking these numbers shortly. 2 theta goes from 180 to 270, so forth and so on. So we have exactly 8 situations. And you can see if I double 45, 135, 225, 315, because I'm going up by 45s, these are quadrantal angles. Okay, and I'm going to get our result by looking at the sine curve. Okay, so in other words, from 0 to 45, if theta is increasing, then 2 theta is going from 0 to 90, and therefore, if I'm looking at my graph here, okay, the actual sine curve goes from height of 0 to a height of 1. And in the next interval, from 90 to 180, it goes from a height of 1 to a height of 0. Okay, so it's increasing here, it's decreasing here. From 180 to 270, it's decreasing, but it decreases from 0 to negative 1. And from 270 to 360, you can see it's increasing, right? It's going up from left to right, we're going up. It goes from a height of negative 1 to a height of 0. And that's how I developed this chart. Okay, now from this chart, I can make a sketch of what the curve will look like. Okay, so when theta goes from 0 to 45, I'm looking at what happens. Theta goes from 0 to 45 at that interval. And in this case, sine of 2 theta is going to go from 0 to 1. Okay? And when we go from 45 to 90, sine of 2 theta is going from a distance or a length of 1 down to 0. So that gives us our first petal. And what I'm going to do to keep our heads straight about this, I'm going to put in little arrowheads to show the orientation or the direction the path is traversed. And since this is going to get a little complicated, I'm going to put a 1 here and a 2 here and circle them to indicate that this is the first leg of the path, This is the second leg of the path. Okay. Now, as we go on, we're now going to look at what happens as theta goes from 90 to 135. Okay. And in that interval, sine of 2 theta, which is r, is going to go from 0 to -1. So it's going to go through negative values. And we've learned that if you have r is a negative value, it flips it. So what's going to happen is that will give us a third leg of our journey to here. And to get the, well, to get the fourth leg of our journey, okay, as theta goes from 135 to 180, okay, we're going to go from, through negative values, r is going to go from -1 to 0. So in other words, when we're here, it'll be flipped the other direction. So we're going to go, this will be the fourth leg of our path. Okay. Now, before we go further, what I'd like to do is indicate what's the coordinates are. So this point here occurred when, well, it has an r value of 1, right? Because we're putting this in polar form, and a theta value of 45 degrees. Okay, so that's the tip of our first petal. Okay, our second petal down here, now don't forget, this would be 135 degrees. So that's our theta, but don't forget it was reflected back. So that would be -1 comma 135, and that's the tip of our second petal. Okay, continuing on. As theta goes from 180 to 225, so I've got the little 45s marked off from here to here. Okay, 2 theta is going from 360 to 450, and you can see that the sine of 2 theta, which in this case is r, is increasing from 0 to 4 to 1. Okay, so if we're going here to here, it's increasing from 0 to 1. So this would be the fifth leg of our journey. Okay, and then the sixth leg of our journey, we're going from 225 to 270. And again, we're in positive value. So r, which is sine of 2 theta, is going from 1, but it's shrinking down to 0. So this is the sixth leg of our journey. And again, let's indicate here what that point would be. And that would be 225 degrees. And the r's were positive in that interval. Okay, so almost done. Okay, so what I'm doing is I'm marking off here. This is the first leaf, the second leaf or petal, the third petal, and now we're starting in the fourth petal. Okay, and now as theta goes from 270 to 360, you're going to notice we're going through negative values. So anything from here to here is going to be reflected up into what we would call quadrant 2. Okay, so when we go from 270 to 315, okay, we're going from 0 to -1. So we're going to come up from here. We're going to hit here. This is the seventh leg of our journey. And to go from 315 to 360, again, we're going from r is -1, which is out here, down to r equals 0, which brings us back to the pole. Okay, so this is the eighth leg of our journey. And let's give this coordinates here. That would be 315 degrees. And it was flipped. So that would be that point. Okay, so at this point, you can see that we went from 0 to 360, and we had 4 petals. So When n is even in a polar rose, you get twice as many petals. So n is 2, you get 4 petals, and we created the complete polar rose in precisely 360 degrees. So that's what this indicates here. Okay, and a couple of interesting things. If you count the number of zeros here, 1, 2, 3, 4, 5, 6, 7, 8, then you will realize that this polar curve goes through, including a starting and ending, the pole a total of 8 times, which is kind of interesting. And each of those are going to have a different coordinate. So in other words, this would be 1 comma, or rather 0 comma 0 at the beginning, it's 0 comma 90, so forth and so on. It goes through. Okay, so that would be, sorry, yep. So that would be a discussion of r is 2 sine theta when n is even, and that's a polar rose. And we're going to do another one of these with r equals sine 3 theta, and we're going to find out that that's going to give you a complete polar rose in 3 petals, because n is odd, and only 180 degrees. So I'm going to remind you that I set this all up on Blackboard for you, so you don't have to worry about copying it down. And before we go on to the next one, why don't you see if you can make a sketch of r equals sine 3 theta, make yourself a similar table. Okay, we're still going to use the same diagram, and we'll see how it works for you. Right, until then.